Okay, so just kind of two little formulas to remember with a direct variation. So direct variation comes in the format y equals k times x. And k there just would represent a number. It could be any number. It could be positive. It could be negative. But it's just going to be a number. It's not going to be an imaginary number, just a real number that's positive or negative. And they call k the constant of variation. So whatever that number is, when you actually have an example that has some specific information, that's going to be your k value. Okay, so just as a tiny example here, before I get going on any of the examples, if I gave you the equation y equals k times x, and I said let's get k by itself on one side, what would you do to do that? What do you think? Divide by x. This is one of those literal equations where it doesn't have any numbers, but we can still kind of manipulate it a little bit. So to get k by itself, I would divide both sides by x. So kind of a related formula. If you don't know the k value, you can find it by dividing. If you have a graph, y coordinate divided by x coordinate. If you have a table, y coordinate divided by x coordinate. If you have an equation, it'll be a little bit easier to see. But if you don't know it, you can figure it out if you have some information. Now, the only other thing that maybe would not be super obvious about this is the direct variation always goes through one point. And that would be, if you have a graph, it always has to go through 0, 0, no matter what the k value is, because it's just some number times x. So if I were to plug in 0 for x, no matter what I multiply that by, that would make the y value 0. So anytime you have a direct variation, if you have a graph, the easiest way to tell if it's a direct variation or not is if it goes through the origin. So that's going to be our first example here. I'm just going to give you 3 graphs, and we're just going to say yes or no. Is this a direct variation? And if we think it is a direct variation, then we're going to write down the k value and the equation here. Let me grab a highlighter. Okay, easiest way to do a direct variation on a graph. Does it go through the origin? All right, so like this one does. This one goes through 0, 1. So without even doing anything, I know that that one's not going to be a direct variation. It doesn't go through the origin. The last one does go through the origin. It has to go through 0, 0 if you have a direct variation. So this one would be a yes, and this one would be a yes. The one in the middle would be a no. So they said in the directions, if it is going to be a direct variation, could we figure out the k value? Now, there's a couple ways to do it. Anybody know how you might look at the graph and figure out what the constant of variation would be, or what would it be in terms of the graph? If it's y equals k times x? It's just the slope. Okay, if you have it, the k value is just going to be the slope of the line. That's literally it. So if you want to grab just 2 points that go right through a corner, and I'm just going to go ahead and grab the origin and then the next point I see. Easiest way for me to tell you to find slope. Go from left to right. If you have to go up, then it's going to be a positive slope. So I'm going up 1 and then rise over run over 2. So the k value there, I'm going up 1 over 2. The slope would be a half. And then the actual equation then would just be 1/2 x. Okay, now I'm going to write this, but you don't have to. Sometimes these are written in the format like it would be y equals x over 2. That's still a direct variation. The k value is a half. Sometimes they'll put the variable in the top. It just kind of depends on how the question might be presented to you, but those are both the same. Y equals 1/2 x or y equals x over 2. Those are the same equation. Can you guys tell if you look at the last graph, like if I just grab 2 points that go right through a corner, can you tell what the slope of this last picture is? What do you think? -3/1. So your k value here, -3/1, or just -3, however you want to write it. And then the equation would be y equals -3x. And there's no other way to write that. Is anybody question about finding a direct variation from the graph? All right, now, if you guys have a table, okay, hang on 1 second, let me grab it. The x coordinate is the same. So and sorry, these tables are like really dark, but the table part on the left is the X, the right is the Y. If you can't read that very well, it's really dark. So to check here, the K value has to be the same for every single one of the points, and it has to be the Y coordinate divided by the X coordinate. So I literally just grab these, like 4 over 2, 8 over 4, 32 over 16. If they all reduce to or divide to be, these are all 2 in this case. If they're all the same, then for sure this is a direct variation. So I would say yes. My K value would be 2. And if they ask you to write the equation, you just write y equals 2 times x. And this would be easy to check. Like if I did the first point is 2, 4. If I do 2 times 2, that's 4. The second point is 4, 8. If I do 2 times 4, that's 8. You can check these really easily. You just got to make sure every y coordinate divided by its corresponding x coordinate is the same for every single point in the table. If one of them is not, then it's not a direct variation. So for this next example, like we'd go 9 over 27, 10 over 30, 20 over 60. Now these are all going to be fractions, but do they all reduce to the same thing? Yes. Okay, what do they reduce to? 1/3. All right, so all these are 1/3. As long as they're all the same, that is your K value. Now, there's kind of 2 ways I could write this. I could write this y equals 1/3 x. That's probably how I would write it. But it could also be presented as x over 3. Either one of those is technically correct. Your K value there is 1/3. All right, and then the last one real quick. 22 divided by 11, that's 2. 32 divided by 16, we actually did that in that first table. That's also 2. 40, well, I can't, fail. Okay, 42 divided by 7 is 6. And one of these is not like the others, right? So this ruins everything. So this is not a direct variation. So you could just say no or whatever. You don't have to write out a bunch of words. But if one of them is not the same as the others, then you don't have a consistent K value. So you don't have a K value. So it's not a direct relationship for that last example. Does anybody have any question about picking it out from a table? Okay, the final way they're going to ask you to determine if it's a direct variation is just by giving you an equation. So if you have an equation, you just got to see, can I write it in the format y equals some number times x? The easiest way I can tell you to figure that out if you have an equation is just get y by itself on one side. So my first little example here, I have 4y equals 5x. So just got to manipulate that a little bit to get y by itself. So I could write that as y equals 5/4 x, or I could write that as y is 5x over 4. Either way, I don't have anything added or subtracted to the side. This is a direct relationship here. The K value would be the 5/4. So that first one is a direct relationship. Can you guys, for the second equation, I've got 3y equals 9x plus 6. Can you tell without doing anything, yes or no for that one? Is that a direct relationship? No way. And I mean, you could go through and solve this for y. These are all divisible by 3, but if you get y by itself here, you get 3x, and then you have plus 2. It doesn't matter what it is. If you have something added or subtracted, that's not a direct relationship because you don't have just some number times x. I have some number times x plus something. That's not a direct relationship. It's just y number x done. Otherwise, it's not a direct variation. Does anybody have any questions? Now, the rest of these questions are going to ask you to, they're kind of 2 problems in one. They're basically going to give you enough information to figure out your K value. They're going to ask you to write an equation, and then they're going to ask you kind of like a secondary question, like use your equation to find another answer. So it says here, the ordered pair, so this is going to be for my first one, 420, is from a direct variation. Find the constant of variation K, and then write the equation of the direct variation. Okay, all you have to do, if you have a direct variation, the K value should just be y divided by x. So it tells me in the directions, this is a direct variation. So my K value, I'm just going to use the point they give me, which 4 is the x coordinate, 20 is the y coordinate. So to get the K value, just take your y coordinate, divide by your x coordinate, and that's your K value. So this one's going to be 5. Now, to actually write the equation, the direct variation, y equals k times x. So I would just write y equals 5x for this particular example. That's my equation. My k value is 5. Then they're going to ask you the secondary question. So this one says, find y when x is 6. Now, all you have to do for that is just use your equation. So if y is equal to 5 times x, and they want us to plug in 6 for x, find y when x is 6, you literally just do 5 times 6. Y is 30. It's kind of two parts to the answer. So the y value when x is 6 is going to be 30. And that's all you have to do. The one next to this is a little tricky because it has a fraction, but if it's a direct relationship, I have this point, the k value is just the y coordinate. For this example, it's 1/3 divided by the x coordinate. Okay, now you can of course use your calculator if you want to for this, but I'm just going to give you a little quick tip. If you have to divide a fraction by a plain number, so if I have 1/3 divided by 3, if I would think about dividing by something is the same as multiplying by its reciprocal, I keep that 1/3, change that division to multiplication, and to flip 3 over or do the reciprocal, that would be 1/3, which multiplies straight across the top, straight across the bottom would give you 1/9. If you actually look at that, the k value there is going to be 1/9. What you end up doing, that number, which is 3, I should have probably used a different example, but the 3 and the denominator of the fraction, they just get multiplied together if you want to kind of save yourself some time. Or you can use your calculator, but 3 times 3 is where the 9 ends up coming from there. Okay, so then there's kind of two ways I could write this one. I can write y equals 1/9 x, or I could write y equals x over 9. Both of those are correct. So whichever way you like better. And then almost all these questions ask you kind of a secondary question. Once you've got your equation, this one, now you make sure you read the directions because it's a little different than the one we just did. This one says find x if we know y is -4. So make sure you plug it in for the correct variable. So if you want to use that very first equation, I would say -4 is 1/9 times x. Or you could say -4 is x over 9. Either way, probably the easiest way to solve that is multiply both sides by 9 to get rid of that fraction, and x is just going to be -36 there. Is anybody having a question about any of the direct variation stuff? We're going to do inverse on the back. Okay. Now, these direct, you guys have worked with linear equations that have slopes and things like that, but inverse variation, this is probably going to be totally new. Now, an inverse variation is of a similar format, but it's different than what we just did. Y equals k over x. So this is a fraction. Variable is in the bottom. K would still represent any number, so it can be in the top. And the constant of variation is still k. And I'm just going to write just a couple examples because this can appear kind of weird ways. So let's say I had, like, I don't know, I'm just going to make something up. Let's say I have y equals 4 over x. That's pretty straightforward, right? The k value would be 4. Let's say, though, I'll give you a couple that are maybe a little bit weirder looking. If the variable's in the bottom, though, if I have an x in the bottom, or it could be a different letter, then it's going to be an inverse relationship. So let's say I had something like this. Let's say I had 3 over 4x. Does anyone know what the k value would be there? It's 3/4. Yeah, it's. I know it looks weird, but it would be 3/4. So the variable's in the bottom. It's going to be an inverse relationship. It can appear in that format though, because I got the 3/4. Let me do one more example. Let's say I gave you y equals, let's see. Let's say I had, I don't know, 1 over 5x or something like that. If I had 1 over 5x, it's an inverse relationship because the x is in the bottom. Does anybody know what the k value would be for that one? 1/5, yeah. So it can be a fraction in some of these problems. So just to show that to you. But if your variable's in the bottom of a fraction, then you're going to have an inverse relationship. Now, sorry, I didn't probably need to give you guys all those, but just as an example. Now, if I told you to take that original equation, y equals k over x, and I said, let's get k by itself on one side, what would you do to get k by itself if you had y equals k over x? You would multiply by x. So in this case, both sides would get multiplied by x. So if you don't know the k value and you have x and y coordinates, you can figure them out by multiplying them together. So it's just the opposite of what we did on the front with the direct. So the actual equation is y equals k over x, but if you need to figure out that constant of variation, you can take x times y. The way I remember it is for direct, you divide. They both start with a d. For inverse, you're going to multiply. So if you want to see, these are going to ask you for these tables, is this an inverse variation? To check here, the k value would have to be the x coordinate times the y coordinate for every single set of points to be consistent. So if you want to just look at this table, like I have the point 2, 15. 2 times 15, that's 30. Then I have the point 4 and 7.5. So 4 times 7.5, that would also be 30. 3 times 10 is 30, 2 times 15 is 30. As long as they're all the same, that's your k value. So for this first table, k would be 30. Now, when you write the equation, if it's inverse, it's y equals that number 30 over x. Now, this one I could check really quick. Like 2 times 10 is 20, 8 times 4, 32. Those are different. This is not going to be an inverse variation. I'm not even going to do anything else. If one of them is not consistent with another, then it's not going to be an inverse relationship. And then the last one's a little tricky because it's got decimals. But if you take 0.2 times 40, that is 8. 0.5 times 16, that's also 8. I don't know why they put 1.0 and 8.0, probably just trying to be fancy, but that's 8. And 2 times 4, the last thing, that's also 8. So this one is, and your k value would be whatever that same number is for each 8 for that example there. So the equation would be y equals 8 over x. These are easy to check. If you've got your equation, just plug your x value in, see if it gives you the y value they have in the table. Questions about the inverse? Now, if they give you information about an inverse, this says each ordered pair is from an inverse variation. So automatically, that'll tell me the k value is x times y. It says find the constant of variation k. So if my point is 2, 5, then I literally just do 2 times 5. The k value would be 10. Write the equation. So y equals 10 over x. And then, like I was telling you guys on the front, most of these will ask you a secondary question. So this one says, find y when x is negative 3. So I've got my equation. Y equals 10 over x, which is negative 3. And in that particular example, I mean, if you want to write a decimal, you can, but that fraction doesn't reduce. I would just leave that. If you can actually divide, go ahead and do that or reduce the fraction, but in that example, you can't really do anything else, so I would just leave it as 10/3. All right, and then I've got one more here. The k value, if you have an inverse variation, is the x coordinate, which for this example is 1/4, and the y coordinate, which is 28. So what is 1/4 times 28? 7, yeah. So this is just a nice number here. Now, the actual equation, we're going to plug the k value in. So it's y equals k over x. K ends up being 7 for this. So it'd be y equals 7 over x. Here's my secondary question. Find x when y is 2/5. So in for y, make sure you put it in for the right variable. So I'm going to put 2/5 in place of y would be equal to 7 over x. Now, for that example, I would just do like a little proportion real quick. Just cross multiply. You get 2x. 5 times 7 is 35. Divide by 2. And if you want to just go ahead and leave that, 35 over 2 does not reduce. If you want to write that as a decimal, it's 17.5. Is anybody having a question? These are not terrible if you can remember these couple little formulas for the direct and the inverse. Okay, now the last thing. This is going to be an application question, so they're going to give you some information. Now, you don't have to use X and Y. I usually don't in these questions. I usually try to use maybe like a word from the problem to define my variables. So if you want to use X and Y, though, you can. So I'm going to show you kind of quickly how to translate these into equations. So this says your class volunteers to pick up trash at the local park. Okay. It says the time it takes to pick up the trash varies inversely with the number of volunteers. Okay. I'm just going to use T for time. The word varies is literally going to translate into an equal sign. So the time it takes to pick up the trash varies. So I'm going to say T equals. All right. And then it says inversely. So whatever I use for my variable following this is going to go inverse in the bottom of a fraction. So it says inversely with the number of volunteers. Maybe I'll just use V for volunteers. Okay, so an inverse relationship means I have K over my variable. And in all the other examples, we've just been using X and Y, but I'm going to use T and V here. So T varies inversely. So the variable is going to go on the bottom with the number of volunteers. Just don't forget to put K in there because you got to find the constant of variation. That's the main thing people will mess up on these questions. They'll forget to put a K. So I've got this K in there. Then they should give you just enough information to figure out what the K value is. So here it says it takes 3 volunteers 85 minutes to clear the trash. So the 3 volunteers, I'm going to put 3 in place of V. And 85 is the time in minutes. So I don't know why I just put that equal to 3. Sorry, I'm going to plug that in for the volunteers. And 85, I'm going to plug that in for the time. So since this is in minutes, if we do this question, our answer will be in minutes, which we could convert if we needed to. But let me plug that stuff in. So I have 85 minutes in for the time. I don't know the constant of variation. That's the K. We're going to use this to figure it out. But I know that 3 volunteers can clear the trash in 85 minutes. All I got to do to find K real quick, just multiply both sides by 3 there. So this ends up being 255 as my K value. All right, so just a general equation for anything for this situation. The time it takes to clear the trash is going to be 255 divided by the number of volunteers. So that would be a general formula for this. So then it says, how long is it going to take if we have 5 volunteers? So we're going to find the time. So T is our variable here. And I'm going to take 255. And then in for the volunteers, it says if I have 5 people doing this, so you just take 255 divided by 5. So then this ends up being 51. And this would be in minutes, since the other part of the question, they put it in 85 minutes. So our answer is going to be in the same units, which would be minutes. Is anybody having a question? Okay, I got one more. Now the last one is not an inverse. The last one's direct. Okay, so this says your distance from lightning varies directly with the time it takes you to hear the thunder. And you can use whatever letters you want. If you want to use X and Y, you can. But I'm going to say your distance from the lightning, I'll just use D. And then the word varies is going to translate just into an equal sign. So the distance varies. So I'm going to write D equals. Directly just means I'm going to do K times whatever variable follows this. This says varies directly with the time it takes you to hear the thunder. So maybe I just use T for time here. And if you guys want to use different variables, you're welcome to do that. But it's kind of like the first part, whatever's first varies. So that variable equals, and then K directly times your next variable, or inversely K divided by your next variable. So then they're going to give us just enough information to figure out what the K value is. So it says if you hear thunder 10 seconds after seeing lightning, you're 2 miles away from the lightning. If you guys wanted to think about that as a point, maybe 10 seconds is the time That's kind of where we're used to seeing the x in these other equations, and then the distance we're 2 miles away, so it'd be kind of like that. You can just plug that in. So distance 2 miles away, the time 10 seconds, divide both sides by 10 there. 1/5 would be your k value. So if we need to write a general equation, the distance we are away from the lightning is going to be 1/5 the time it takes for us to hear the thunder. And then they're going to ask me a secondary question. How many seconds would it take? So we're going to solve for the time here. How many seconds would it take for you to hear the thunder if the lightning is 4 miles away? So that means the distance is 4 miles away. It'd be 1/5 multiplied by the time it would take me to hear the thunder. Easiest way I could tell you to solve that would just be get rid of 1/5. I would just multiply both sides by 5 real quick. That would cancel that 1/5 out. And then 5 times 4 is going to give you 20. And this will be the time. Since the original example here was in seconds, then our answer is also going to be in seconds. Is anybody having a question?